In this video, we're going to approximate the area under a curve using rectangles. It says use the right endpoint approximation to approximate the area under the curve of f of x equals 2x over 5 plus 1 on the interval 1 to 7 using 6 rectangles. So when they tell us that we want to find this right endpoint approximation for 1 to 7 and they want us to use 6 rectangles, they're basically telling us the width that they want us to use for each rectangle. We need to find that by saying that change of x, which would be the width, is equal to, I'm going to label this a and b. So this is b minus a divided by n is the number of rectangles that I'm going to split that into. So I get 7 minus 1 divided by 6, which is 6 over 6, which is 1. So change of x for this problem is going to be 1. And that's going to be like the width of our rectangle. Now, how do we find all the heights? Well, the heights are going to be based off of different x values. Now, they say right endpoint approximation, so I don't want to start at 1 here. I actually want to start at something different than 1. Usually we would say, and we'll just do it here, we'll say x sub 0 is 1. And then x sub 2, or x sub 1, I mean, is equal to, this would be 1 plus change of x. X sub 2 would be 1 plus 2 change of x. And then we're going to just say that x sub 3 would be equal to 1 plus 3 change of x. And this is going to continue until we get to basically 6 triangles, but 6 rectangles. But we don't want this, we don't want to start at the left end point. We actually want to start at this x1. So I'm going to kind of cross this out. We don't want to start here. We want to start at our our end point that's on the right, so the right side of the first rectangle. And we want to end with our last end point, which is 7. So this is really 3 times 1, so this is we're at 4 here. We would want to do the same thing. I'm going to put a comma here, but we're going to write x sub 4 is 1 plus 4 change of x. X sub 5 is 1 plus 5 change of x. And then x sub 6 is 1 plus 6 change of x, which is equal to 7. So this is our farthest right endpoint. Now what we're going to do is we're going to say that the area for this triangle is going to equal, if I take f of x1, I'm getting a y value here. So I take x1, which is, in this case, would be 2, and I'm finding a y value, which would be my height for my rectangle. So I've got the width, which is change of x, that I need to multiply times f of 1, which is the height. And I would need to add that with f of x2 times change of x plus f of x3 times change of x plus f of x4 times change of x plus f of x5 times change of x plus f of x6 times change of x. Now I'm actually going to factor change of x out. So I'm going to say that the area is equal to change of x, when I factor that out, times f of x1 plus f of x2 plus f of x3 plus f of x4 plus f of x5 plus f of x6. And then f of x1, so that would be, change of x is really just 1, so I'm going to take 1 times f of x1. This is f of, this would be f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6 plus f of 7. Now I'm going to do a bunch of work in the calculator here. So I'm essentially going to plug 2 into this function here. Try and show some of this. So we're going to do 2. Actually, let's get a fraction in there. So 2x over 5 plus 1. And then I'm going to store these numbers. So I'm going to say 2 stores x and plug it in there. We get 9 over 5. So we've got 1 times 9 over 5 plus, we're going to store 3 as x. We get 11 over 5. And so I'm going to do this for each piece here. So plus, do 4 stores x, 13 over 5. I can see a pattern starting here. So 2, 11, 13. So this one for 5 is going to be 15 over 5. For 6 is going to be 17 over 5. And for 7 is going to be 19 over 5. Now I want to add all these together. So we're going to go well, if I add, let's just add the 9 plus 11 plus 13 plus 15 plus 17 plus 19. We get 84 over 5. So we end up with 84 over 5 times the 1 will just be 84 over 5. So this is the area using right endpoint approximation.